Good morning, students. Our today's topic in the topic of metals is properties of metals. So actually we will discuss properties and structure of metals and alloys today. So concentrate yourself. A lot of concepts will be involved. So we are going to start. So here is the periodic table. These two columns, group 1 and group 2, which are representing by dark gray color, are reactive metals. Between group 2 and group 3, here are transition metals, which are represented by the medium gray color. And here are poor metals that are represented by the light gray color. Okay, metals have the following physical properties. The first property is lustrous, that is actually shiny surface. Malleable, ductile. When a force is applied to a metal, the atoms can slip over one another. Actually, in metals, atoms are arranged in an orderly manner, and when a force is applied to it, the atoms can slip over one another. This is because the layers of the atoms in the metals can slide over each other without the structure breaking down. So due to which the metal can be reshaped into others without breaking. The next property is good conductors of electricity. So electricity can pass through them because free electrons are available in metals. Good conductors of heat. This is because metals have a sea of the free electrons that are mobile to conduct electricity. High densities, because atoms are very close to each other. They are packed in a very compact form. That's why they are having high densities. Solid state at room temperature. Effect of hammering shaped without breaking. So this we have studied earlier. When a force is applied, the layers of the atoms can slide over one another. Effect of tapping, a ringing sound. So when we tap on the metal, a ringing sound is heard. Strength is high. A few examples are magnetic. So not all metals are magnetic, but few examples are magnetic. High melting and boiling point with a few exceptions, such as mercury, which has melting point of -39°C, and metals in group 1 and 2, which have generally lower melting and boiling points. So here is the structure of the metals, close packing of atoms, and when force is applied to it, the layers of the atoms can slide over one another. So layers of the atoms have slipped. And when heat is given to the metals, thermal vibration transfer the heat from one atom to another. So they vibrate each other, collide with the other, and heat is transferred. So in this way, heat is transferred from one place to another. And the next is, this is negative end, this is positive end, so electrons flow. So these are the properties of the metals. Next property is, metals have the following chemical properties. Metals react as a reducing agent. So this is the first chemical property. Metals lose electrons to form positive ions. Metals react with oxygen to form basic oxides. Reactive metals react with acids to liberate hydrogen. Some metals and non-metals react together, produce salts. For example, sodium, a metal, and a chlorine, a non-metal. And when they react with each other, salt is produced. If zinc or copper is heated with sulfur, so look now, zinc or copper are going to be heated with sulfur. The metal sulfide is formed, and here you can see with zinc sulfur will form zinc sulfide, and with copper sulfur will form copper sulfide. Here are some extremes in the metals. The lightest metal available in the world is lithium, has a density of 0.53 grams per centimeter cube. The heaviest metal available in the world is osmium, has a density of 22.48 grams per centimeter cube. Most brittle, manganese and chromium are the most brittle. Lowest melting point, mercury has a melting point of 38.9 degrees C. Highest melting point, tungsten has a highest melting point of 3410 degrees C. Most expensive, platinum has the greatest commercial value, that is most expensive metal available in the world, that is platinum. The rarest metal that is available in the world is rhodium, is the rarest natural metal on earth. The most abundant metal available in the world is aluminium, makes up over 8% of the earth's crust. Okay, exceptional metals. Most metals are hard, but sodium is so soft that it can be cut with a knife. Most metals are not magnetic, but iron, nickel, and cobalt are the magnetic metals. So these are very, very important points, students. So you have to understand and learn them, because short questions come from these topics. Sometimes it is if we are asked to give the name of the rarest metal, sometimes the most expensive metal, sometimes the magnetic metals. So you have to remember all these points. These are very, very important points. Most metals are silvery white or silvery gray or blue. Gold and copper are exceptional because they are colored. Gold is a bright yellow and copper is brown. So gold and copper are called colored metals. All metals are solid at room temperature except one, mercury, which is a liquid at the room temperature. The next thing that we are going to read is the alloys. So first, the definition. An alloy is a mixture of two or more metals. Some alloys also contain non-metals. Properties of metals and alloys. So here is a comparison between pure metal and an alloy. Pure metal is soft and weak, whereas alloys are hard and strong. Atoms can slide over each other easily, as atoms are of the same size in metals. But in alloys, atoms cannot slide over each other easily, as foreign atoms are of different sizes and disrupt the orderly arrangement of the metal atoms. So in alloys, foreign atoms are introduced, which actually disturb the orderly manner of the atoms of the metal. So that's why atoms cannot slide over each other easily in alloys. Metals can be easily corroded, but alloys are corrosion resistant. Metals can lose metallic luster easily, but alloys metallic luster preserved. Structure of metals and alloys. The atoms in a pure metal are closely packed and arranged in an orderly manner. When a force is applied, the layers of the atoms slide over one another, making the metals weak, and that explains why metals are malleable and ductile. So this is the diagram. So atoms are closely and orderly packed. When force is applied, layers of the atoms slide over each other. This makes the metal weak. So this is the property which explains that metals are malleable and ductile. In an alloy, foreign atoms of another element are introduced into the pure metal. These foreign atoms disrupt the orderly arrangement of the atoms of the pure metal. This prevents the layers of the atoms from sliding over one another, making the alloy strong and hard. So this is the reason why alloys are very strong and hard, because the layers cannot slide over each other easily because of the introduction of the foreign atoms of the different elements into the pure metal. And here is the example structure of metals and alloys. So these are the structures of the metals. So when external force is applied on the pure metal, metal atoms slip over each other. But in an alloy, you can see this bigger atom is a foreign atom of another element which is introduced into the pure metal. So because of this, the orderly arrangement is disturbed of the atoms. So when a force is applied, so the layers of the atoms will not slide over each other easily. So this is the reason alloys are very strong.